So looking at quadratic functions and their properties, let's look at this question one. Graph the following function by starting with the graph of y equals x squared and then use transformations, shifting, compressing, stretching, and or reflections. Click the graph. So let me back up here and look at the actual function that we're dealing with. So notice that we want to graph f of x equals 4/3 x cubed. I'm sorry, x squared. So remember, a second degree function is called a quadratic function, and a quadratic function will take on the shape of the parabola. So this would be the tool you'd be using is this one. So you'd be clicking that tool. Again, I'm not going to do all that here, but this just kind of gives you the general idea of how to go about navigating this. But this would be the tool that you would use. Again, it does say click the graph to choose a tool in the palette. So once you click on this, you'll click on the graph. And then you should have this little pop up. Now, all we have to really fill in are these 6 little areas. Since we have this 4/3 x squared, notice how this 4/3 is on the outside of the function. So if it's on the outside of the function, it affects the graph vertically. This is called a vertical stretch or compression. So if I was graphing the function, if I had the first function is y equals x squared, remember the easiest points to graph are -1, 0, and 1. And -1 squared would be 1, 0 would be 0, and 1 would be 1, because 1 squared is 1. If I was wanting to graph y equals this 4/3 x squared, what should happen is the y values should change by a factor of 4/3. So the -1 should not change, the 0 should not change, the 1 should not change in the x values, but each of the y values should be, since this is greater than 1, 4/3 is just a shade over 1 because 3/3 is 1. This should be called a vertical stretch. The graph should go a little bit further from the x-axis. It should be pulled further away from the x-axis. So if you multiply the 1 by 4/3, you're going to get 4/3. If you multiply 0 by 4/3, you're still going to get 0. If you multiply 1 by 4/3, you should get 4/3. So that's just going to be a shade more than 1. So if I was to look at this on our graphing calculator, if I look at the parent function, which is y equals x squared, then if I put this 4/3 in, so I'm going to use the fraction button. I'm used to using the alpha key, alpha, and then this F1 up here, number 1. So I can put the 4/3 in this spot, and then come out and put the x squared in. If I then graph this, oops, I still got my step plot on. So if I go back to y equals, see where it says plot 1 up here. If we highlight that plot 1 and hit enter, it'll remove that plot 1. If I graph it, still don't see anything. Well, remember when we did the stat plots, it changed our viewing window. So if I go to zoom, if I change my window back to standard number 6, it now will generate my graphs for me. So notice that the blue graph was the parent function, and notice that the graph of the red function is a shade higher or further away from the x-axis. That's what's called a vertical stretch. And a vertical stretch is actually going to make the graph appear more narrow. It's kind of closer to the y-axis, if you will. It's going to make it more narrow. So as it grows quicker vertically, it's going to be steeper. In other words, it's going to be more narrow with respect to the vertical. Again, if I look at the table, if I go down here again around -1 and stuff like that. So notice that, -1, 1 was the parent function, and then -1, 4/3 was the one we graphed. Zeros, there are zeros across the board there. And then if we look at the 1, notice that the 1, 1 was an ordered pair, and then the 1, 4/3 was an ordered pair. So that does match with what we're thinking. So I don't really need the technology. The technology is just kind of verifying it. So what should happen is, if I was going to graph this using the tools, all I really have to be doing is changing the 1 to a 4/3, because I do have a vertical stretch or compression. There aren't any other transformations going on in this problem. There's no horizontal or vertical or horizontal shifts. There's no reflections, things like that. So that's all I really have to be doing to graph that function. So if you change the vertical stretch of compression to the 4/3 and then graph it, it should create the graph that we had here on our graphing calculator. So hit the y equals and clear off that one and hit graph again. You should be getting that graph there.